Hello, I'm sorry, some disconnection happened. So I'm sorry for the minor hiccup. We'll start again. So what we were discussing, we have just started the presentation, and this is how it is. Uh, the water itself has a lot of memory in it. So from wherever it goes, it remembers every area, every particle it touches, and it contains stores that memory within it. So it is the largest pen drive one can imagine. So impurities in water are dissolved solids, suspended solids, oil and grease, biological oxygen demand, chemical oxygen demand, and there are certain other things which I have really pointed out here, which you will understand why they are so important. These are sulfides, chlorides, nitrogen compounds, and heavy metals. All these things are things which can actually remove the oxygen and remove the life of water. These are like toxins. So this slide is just to remember, just to make you understand what all impurities are there in wastewater. Now let us understand how do microbes can reduce BOD, COD, and TSS. When we say our microbes can do magic, but how does it actually happen? So what happens is you should consider a microbe. These are some very rare photographs we have arranged for you, and I think you will be really amazed to see how things can work. So
Sanjay,
yes, please.
uh, can you explain me what is COD, BOD?
Sure, I'll come back. I would request you to keep it for the question answer session, and I will definitely come back because we have some limited time. I would
Okay,
I will give it the at the end of the session.
okay.
Okay, so the chemical this BOD COD is an organic matter which needs oxygen to get oxidized completely. A COD is a chemical oxygen demand. For example, any detergent or any alcohol which goes into wastewater needs oxygen to get oxidized. And similarly, any food item or any organic substance which goes into wastewater needs to be absolutely neutralized before it can we can call it clean. So that way you can understand what COD and BOD is. Now these we were coming to microbes. Microbes are chemical factories. They are microscopic chemical factories. There are numerous kind of enzymes. They are intelligent factories. They can produce the enzymes they actually need to digest the food. So the one microbe can secrete n number of enzymes, and they can what they do is the most important part to understand on this slide is that for example there are masons and workers who can convert bricks to from nothing to beautiful buildings. That is the same way microbes can convert BOD and COD from some pollution to their own living biomass. And this god gift or this magic actually helps us in pollution. So this is how it all works. This is the basic thing you should remember. Now, these are some rare photographs I was talking about. See, this is at the microscopic level. When the bacteria are just there in the water, they have not yet eaten up any waste. The whole water is turbid. It looks so unclear. The even light can't go through. And these microscopic organisms have not eaten yet the any BOD COD, but slowly they start eating it. They start becoming better, and they produce certain polysaccharide glue type of substances which can bring them together. Now when this brings them together, they turn into a flock, a very stable strong flock. Every microbe cannot do it, only certain microbes can do it, and we understand what those microbes are. That is why we have incorporated them in our products. So this strong flock, when this strong flock clears the water, you can see a clear water on the last picture, and this is how it looks at the customer side. When these flocks become strong enough, they settle down, and when they settle down, they bring all those suspended particles along with it. Now, this may be seeming little more easier, but microbes are very microscopic organisms. They are very much sensitive to everything which is there in water. So we have to actually have, I mean, those conditions must be very favorable so that they can form and really produce and develop. That is what we will understand. Now, these are some wastewater, important wastewater bio inputs I would like you to give an attention to. Because you may have heard of products where they say we have microbes, we have enzymes, maybe some say we also have nutrients, but just this cannot work. I mean, for a microbe to work, there are so many other things which have to be there. Everyone knows microbes can digest BOD, COD, and they can build a big biomass and clear water. Okay. So, and then they need enzymes to break this organic matter. Enzymes, or even we have in our digestive system, that plays an important role. So microbes, they are enzyme factory themselves, and the enzyme addition in a product helps in speedy degradation. That is true. Then, for example, there are certain instances, or I'll give you an example of a school. In a school, there is less of sewage waste, and there is more of maybe urine waste is more. So there is a particular scenario where nutrients are not coming into the wastewater plant. In that case, we must supplement them with nutrients so that the product or the microbes can work. A similar case is a honey factory, a factory who is processing honey. So honey is a very good BOD source. It is very good sugar source, but there is no nitrogen, no phosphorus in honey. So how will microbes actually degrade that wastewater? So these are some examples. There are n number of examples. Even industrial waste, there is a bigger nutrient problem. So nutrients have a major role to play. Now, this is something important, which is you may have heard of certain herbs and certain powders which can actually absorb toxic gases. So, yucca is one such herb which has the power to absorb gases. It can absorb these ammonia, H2S, methane, any toxic gas, mercaptan, and it will stay there. It will not no longer become a toxin. And it will also help microbes to develop on its surface. So this is something which if we include in our product, it can definitely improve the functioning of microbes. And then this Trigonella phoenum, the name may be seeming complex, but this is nothing else than methi. So you may be wondering, when we make idlis at home, we always, or our grandmothers or mothers, always put a teaspoon of methi in there. So the methi has a very big role to play in microbial activity, because microbial cells are made up of substance which are there in methi. It is called beta glucans, if you would like to know more. So these are certain extracts which definitely help in microbial growth. And then you may have heard over some viral videos of the word polyglue. Polyglue is something which is natural made gluey substance which is found in nature. It is found in plants. It is found in sea animals. All this polyglue is basically polysaccharide, natural polysaccharide. What it does is it binds the suspended solids together, so that microbes find it easier to digest. So these are some important wastewater inputs. Whoever is there in the wastewater industry will definitely, you can use it as all together in a product. You can also use it on an individual basis. So you'll find this useful somewhere in your industry. Now, why these are important, why I'm talking about this, I'll quickly give you two examples and you will understand. See, this is a screen where we have shown that a toxin can actually kill or puncture a bacterial cell. Now, how this can get done is, I'll give you an example. Everyone uses, say, Lysol in their home, or there are certain disinfectants like Dettol is there. people have heard of so many other disinfectants. These can actually rupture the cell wall. So if we don't bind the toxin, they will rupture the bacterial cells. So this is why bio inputs are important, and toxins can be high and low pH, chlorides, sulfides, amines, acetones, anything which can go into wastewater, which can actually kill the cells are toxins. So bio inputs can actually bind these toxins. Another example is, for example, let it be sewage or let it be industrial waste. There is always ammonia and H2S there in the wastewater. And you should now, by after this slide, after this presentation, you will know that one part of ammonia needs 4 parts of oxygen to actually stay there. This will always happen. And one part of H2S always needs 2 parts of oxygen. So all this oxygen gets consumed by these two gases. So there will be no oxygen left for the microbes. So unless we take care of ammonia and H2S in our sewage, in our wastewater, we cannot have a good microbial growth. So that is why these are 2 examples I wanted to give it, and I hope you will appreciate it. Now we'll quickly talk about some innovations which we have done. To begin with, we have some ground when we say this. So these are various examples from our customers. You may see how clear water gets. This is the Nala where you see in the center is a Nala near the Prime Minister's house. This is a PMO. There is a open Nala there, and it was a actual odor problem, and one of our the company contractors has remediated this. So these are some certain examples. Now, so what we have done, our basic major product which has all those bio inputs is Super 24. This is one of our star product, and Super 24 has found very good reception in the market. So what it does is, the #1 property of Super 24 is that be whatever the water given to it, it will always try to create a well settling biomass. I mean, it has all those ingredients in there which will help those microbes become into a flock and settle down. So this is something innovative which we have developed. I mean, this product is just not bioculture. It is so many other things, so many good things which come together to actually help the microbes work. It comes in 2 packings, bulk packings. We have always have the view that bioculture is not a one-time dose. It is a regular affair, because microbes may be able to germinate themselves, but toxins cannot be binded just once. They have to be binded every day. So that is why we should do a bioculture dosing every day. Now this is what I want to show on the simply in terms that Super 24 definitely gives a well forming flock in all sorts of conditions, and that means clear water in all kind of wastewater scenarios. So earlier the people were using cow dung, jaggery, urea, DAP. There are so many other in India. People were importing biocultures, and all sorts of EM products are also there in the market. EM is essential microbes. These are mainly lactic acid, curd based or milk based products. So these are there in the industry. They are still there. But when now you have Super 24, you don't need any of that, because we have, it is something apart. It is not those basic things. Basically cow dung is more of anaerobes. You cannot expect magic out of cow dung. It is from a ruminant, and it is more suitable for biogas production, not for wastewater treatment. Similarly, jaggery, urea, DAP, they are not good enough, and there are better alternatives to urea. There is potassium nitrate instead of urea. So we have all incorporated them in Super 24, and it is already being used in commissioning, in maintenance, to remove filaments, for better MLSS growth in ETPs. This is the short video of Super 24. So thanks for listening. Now we'll go ahead. The other major product which I want to tell you, or an innovation which I want to tell you, is Oxy Super. Now, Oxy Super is a product which can actually release oxygen in wastewater. Now, you may say that we have aeration air blowers in the wastewater, but this is not to be confused with air blowers. Actually, the oxygen must be there in the equalization tank, the collection tank, or places where oxygen cannot be done. For example, open nalas, septic tanks, and we must have a chemical input to increase the bioactivity. And these are nano oxygen bubbles which can be generated from Oxy Super. And this product goes along with our product Super 24. When Oxy Super is there, the results are dramatically increased, dramatically improved because of that nano oxygen. So this is our product Oxy Super, and this is how it works. I'll keep it short.
वीडियो की आवाज नहीं आ रही वीडियो करो वीडियो की आवाज नहीं आ रही आपकी म्यूजिक बंद करो
So this was Oxy Super. This is some another special photograph which we have arranged. See, this is a flock, and if the oxygen penetration is there, this is how it looks. And if the oxygen penetration is not there, if it is a septic sludge, if it is a rotten sludge, how the flock looks. So this is some thing which you will will make you understand the importance of oxygen. And that is why Oxy Super is required. If we disconnect from this webinar, I would request you to join back again. I think there is some 40-minute time limit. My team will get the webinar started again. If it in any case you disconnect. Okay, so this is if you can look through the photo